Hey there. So welcome to the first video in the PDE series, and today we are going to be looking at this differential equation right here. So whenever we try to solve a new type of differential equation which we haven't seen before and we don't really know how to solve, the best thing to do is just guess a few solutions. So can you pause the video right now and guess a few solutions? So firstly, the very first solution that may come to your mind is f of xy is equal to 0, because if you differentiate 0 with respect to x and y, you get 0, and 0 plus 0 is 0. The other one that may come to your mind is, since you're differentiating, you can generalize this solution a bit more by just saying that it is equal to some constant. So when you differentiate a constant with respect to x as well as with respect to y, you get 0. So this is also a solution, and these are just trivial solutions. So can you think of any non-trivial solutions? So one that may come to your mind is x minus y, because if you differentiate with respect to x, you get 1, differentiating with respect to y, you get minus 1, and 1 plus minus 1 is 0. But you may think of generalizing that further by saying some constant times x minus y, because here you did 1 minus 1, so now here you'll do k minus k, and that is still 0. Can you think of anything else? Well, since it's a linear differential equation, the very definition of a linear differential equation is that if you have one solution, you have another solution, their sum is also a solution. So this is a solution, this is a solution, so this plus c is also a solution. What about anything else? Can you think of anything else? Well, if I rearrange this, let's see what we get. So I'll just rearrange it like that. The partial derivative in x is equal to the negative of the partial derivative in y. And this kind of looks familiar because this is kind of suggesting us of a certain function which doesn't really change when you differentiate it. What function doesn't change too much when you differentiate it? The exponential function. So if you think about it, you can also say that f of xy is equal to e to the x minus y is also a solution. I'll leave it to you to check that for yourself. But now notice that if I multiply this by some constant a, this is still a solution because it's a linear differential equation. So if you have a solution, then the constant times that solution is also a solution. Can you think of anything else? Well, we can add c, because solution plus solution is also a solution. Anything else? Any other generalizations over here itself? Well, you may think of multiplying k over here. So I'll just rewrite it. So it's a bit cramped, but I hope you can get what I mean. Okay, so that is a lot of solutions, and we also generalized them as much as we could. Now, can you think of anything else? Well, how about x minus y squared? Does this work? Well, if you differentiate with respect to x, you get 2 times x minus y, and if you differentiate with respect to y, we want to check if it's equal to negative of, differentiate with respect to y, well, you get minus 2 x minus y, and yeah, they are equal. So this is also a solution. How about root of x minus y? Does that work? So if you see properly here, all we are just doing is we are making up functions of x minus y. So g is any function, any single variable function, and we are just plugging in x minus y into that. And to show you that this general solution also works, we can just do the same thing over here. So if you partial differentiate this with respect to x, you get g prime of x minus y times the partial with respect to x of x minus y and if you evaluate this, then you get negative of, again, g prime of x minus y times partial with respect to y of x minus y. And well, what is this? This is minus 1 and this is 1. So the negative and negative cancel out, and of course they're equal. So as you can see, this any generic function of x minus y will always work. So now it only boils down to either showing that this is the most general possible solution. Now of course you may say that we can multiply by k and add c and that will give us a new solution, and sure, yeah, you're right, but that is still a different single variable function of x minus y. So if we just say any generic function of x minus y, we are basically covering all possibilities. You don't need to multiply by k and add c. So this basically covers all the solutions that we have guessed so far, and now it boils down to either proving this is the only possible solution, or if it's not, then we want to find the rest of the solutions. So we'll do that in the next video. For now, thanks for watching.